This is the fourth of 5 videos in the series that will cover reflection with matrices. Now, reflection is carried out using matrix multiplication. What we do is we take one of these 4 matrices, depending on what reflection we are trying to do, and we multiply that matrix times the vertex matrix. So this matrix would come first in our problem. So depending on, you have to read the directions carefully, because depending on what reflection we're asked to use, that's how we determine which one of these 4 matrices to use. So let's look at a couple of examples. First up here we have a triangle. We're asked to reflect that triangle through the origin. So if you go back and look at the previous page, if we're looking for through the origin, that would be this matrix here, -1, 0, 0, -1. So we start with that matrix. -1, 0, 0, -1. And we multiply that times the vertex matrix of our triangle. So we label those points A, B, and C, and we generate a vertex matrix. A is located at the point -7, 8. B is located at the point -1, 8. And C is located at the point -7, 1. And we're going to carry out matrix multiplication here, which is where we take row 1 and we multiply each column. Then we take row 2 times each column. So that work would look something like -1 times -7 plus 0 times 8, which is row 1 times column 1. Then row 1 times column 2, which would be -1 times -1 plus 0 times 8. And finally, row 1 times column 3. -1 times -7 plus 0 times 1. We will then repeat those steps using row 2. So row 2 times column 1, which would be 0 times -7 plus -1 times 8. Row 2 times column 2 is 0 times -1 plus -1 times 8. Row 2 times column 3 is 0 times -7 plus -1 times 1. Now once we've done that, we're going to go in and reduce each of these to a single number. That would be 7, 1, 7, -8, -8, -1. So those would be our images of our 3 points, A prime, B prime, and C prime. We would go over here and we would graph those 3 points. So 7, -8, 1, -8, and 7, -1. And then we would connect those dots to find our image triangle. Now, you may notice that there are actually shortcut patterns in the form of coordinate rules for these, and I understand that. However, given that we're doing a unit on matrices, I do expect you to show me the work. I want to see the matrix multiplication, not just an answer. So I want to see that work. Let's look at another one. So here we're asked to reflect the quadrilateral across the line y equals x. So we go to our rules and we find the matrix for y equals x, which is 0, 1, 1, 0. And we start with that matrix. Again, that is 0, 1, 1, 0. And we are going to multiply that times our vertex matrix. So again, we just need to name these 4 points and write them as a matrix. A is at the point 1, 6. B is at the point 3, -1. C is at the point -5, -4. And D is at the point -4, 2. And then we're going to carry out matrix multiplication. So again, that's row 1 times column 1, which would be 0 times 1 plus 1 times 6. Row 1 times column 2, 0 times 3 plus 1 times -1. Row 1 times column 3, 0 times -5 plus 1 times -4. And row 1 times column 4, 0 times -4 plus 1 times 2. Then we repeat those steps with the second row. 1 times 1 plus 0 times 6. Row 2 times column 1, sorry. Row 2 times column 2. Row 2 times column 3. And row 2 times column 4. We're going to reduce each one of those down to a single number, which should be 6, -1, -4, 2, 1, 3, -5, -4. Again, that is our image, A prime, B prime, C prime, D prime. So we go over here and we graph those 4 points. 6, 1, -1, 3, -4, -5, and 2, -4. And we play connect the dots. I'm going to move that B because it's going to be in the way. So we connect those points. And the image does look a little bit different, and my pen actually screwed up there, so I have to try that one again. There we go. But it is the same image reflected through the line y equals x. So let's move this B to a more advantageous location. Let's put it on the inside. So we have here A prime, B prime, C prime, and D prime. Now for those of you that are having trouble visualizing this, I'm going to draw in the line y equals x. That is the line with a slope of 1 that passes through the origin. You'll notice that each point is a mirror image across the green line. That's what we mean when we say reflection. So A and A prime are in the same location on opposite sides of the green line. That does it for reflections.